and get on with the show, Don.
All right, I'm Don Golding. Let me get things going here. I'm going to be giving a talk, what I believe is the future of Forth. Let's see. So, Don Golding, I work at Made in Space. I'm a senior electrical engineer. Made in Space makes...
So, Don, while you're doing that, I'd like to ask perhaps for an AI bot board update after you're done with your future of Forth talk.
Okay, I'll do it first. So, here's the board. I have 30 boards made. I've been working 7 days a week, so I haven't had time to work on it. But basically, the stage I'm at is board bring up. It has an ESP32. It's got an SD card. It's got Wi-Fi because using the ESP32. Brad and Dr. Ting have ported over Dr. Ting's eForth to it in C, and they have that working. Brad's got a control interface using the browser working. It's going to control 2 DC motors so that you can have differentially steer the robot. It's got these LEDs are actually eyes for the robot. So it's got 2 forward-facing eyes and then 1 on each side. It measures the current in the motors, so the whole body is a sensor of last resort. It's got a microphone and a speaker. It's got sonar, and it also has a magnetometer, inclinometer, accelerometer. So basically it's got an inertial nav system. I have C code that works really well to turn that into compass headings, which is really important in robotics. So that's the update on that. My biggest interest going forward is AI in Forth and robotic control. And Bill, I wanted to say one thing. I'm going to be involved with a C programmer who has a PhD in robotics using matrices in C to do reverse kinematics on a 6th degree of freedom arm. So I'm curious if you could, it uses matrices in the coding. It'd be interesting to see if your force system can do all that. So anyway, yeah, this is me at the DARPA Grand Challenge. They were doing a search and rescue robot competition where humanoid robots had to go into a building and get people and stuff like that. It was kind of a fun deal. So in 1990, started a company called Andrews Research Corp, and I built a lot of different robots. I built over 2,000 robots, mostly in education, but I did build military robots as well. So this is actually from the Wayback Machine, because I lost the site a long time ago. So I had to go back in the Wayback Machine, but you can find it. Angeles Research Corp, if you have an interest in it. These are some of the things I did, AGV, and some of the areas I wanted to get into with the company are in here. Remote inspection, mining, oil and gas. Robots could do all kinds of stuff for people. And I developed a three-level architecture. I call it the Trine OS, based on the Trine brain. And I didn't even know that until I talked to a biology professor at a trade show. And she told me, when I'm describing the functionality of the 3 levels, she said that's just like the Trine brain. And quickly it's, so at the lowest level, you have motor sensor fusion. So if a sensor sees something, like say a light sensor sees something, the robot will veer the other way. So there'll be an instantaneous override of the motor direction until the sensor doesn't see it anymore. And then it goes back to the direction it was going in the first place. Same things, if the same thing happens on the right, it's gonna veer to the left. If you're in the collision avoidance, you gotta set up for collision avoidance. Now what happens if both the front sensor sees something? Well, what you really want to do is back up, do a pivot turn and go, and then you terminate the behavior. So that's called a behavior. The behavior actually takes control from the goal level, which is really your outer processing loop, and it does its thing. And then when it terminates, the goal level gets control back. So if you're going across the room and you're doing real-time collision avoidance, the goal level says hold a course of 270 degrees, and then when it gets off course because the behavior kicked in to avoid something, when the goal level gets it back, it does an analysis and says, oh, you should be at 269 degrees now, so hold that course. So the interaction between the three layers gives you an intelligent machine. These are some of the robots that I built. The upper right, that was called Ranger, and you see the two big knobs on the side. You just unscrew those and that whole track comes out. That was for the military. The lower right is called Intruder, and that's all surface drive vehicle. You see that it articulates in the middle, and the entire surface is rotating. The middle one is called Advanced Whiskers, that use two boards that were networked together and had a long-range sonar on the top. So the long-range sonar could look around the room, find the door, and tell the base, which I just described to you how that would work, you know, which heading to go on. The robot that's on the black and white track, that was called Stock Boy, and if you look between the two plates on the top, there's a black a conveyor. Is basically flat rubber that is motorized. So then there's two light beams up there. So if it goes over to you know, where a box is coming down on a conveyor and it breaks the light beam, it turns it on. It turns on the belt. It pulls the box onto the robot takes off, and you notice the light array in the front can detect people walking in front of it, and it will stop if it sees somebody, and once they pass, it'll keep going. And if you want to change the path, you just change the tape on the floor, so it goes to the other side of the room and it drops it off. This was for a science museum in Atlanta, Georgia. The upper right up in here is that's Whiskers. That was my cheapest robot. I sold over 2,000 in education. I developed a high-level language in Forth, but Forth was still available, and I had a curriculum, and students would learn basic programming skills in 10 hours. And I used do loops. You know, it was a kind of a mixture of English and Forth. They did colon definitions and all that. So they learned, you know, Forth and also intelligent robots in 10 hours time. So this is my Trine OS, and at the bottom, I should have reversed this. The instincts are the lowest level, so they're the highest priority, the lowest amount of intelligence. Tasks and behaviors are like the middle. And then the outer level is your foreground task. Tasks and behaviors is done in the background as well. So on the robot, I built the first man-packable robot before iRobot built their PackBot. And I built it for U.S. Special Forces, John Blitch. And, you know, once John got money, all the money went to iRobot. But anyway, so I have some specs here on what's going on with the military robot, because I'm going to talk to you about space robots here in a second. So the military wanted to have a robot that could give them standoff range of a minimum of 1 kilometer, and we tested it out to a mile. We had a real-time color video camera link. We were using RS-232 9600 baud modems. The low speed is really critical. You think about a deep space probe. You know, if you had robots mining, say, Pluto, it'd be a very low bandwidth data link, and that's where Forth comes in for space robots. I was using a 68AC11. It was the new micros. You remember Max Forth? And we had 32 kilobytes of PROM. That was my actual Forth code that I wrote. And of course, there was 32 kilobytes of battery backed up RAM so that you could download new code. And when you turn the robot off, because I used the battery to back up the SRAM, it would remember your code. And it used just RS-232. Forth has a long history in space. If you do NASA space Forth applications in Google, you'll see a lot of stuff come up. This is just an example. These people did a real-time expert system using Prolog that was written in Forth. And it was actually funded by NASA itself. That was back in '87. It was in the Applied Forth Research Journal. I used to get that. Okay, so imagine this is a space mining robot picture I got off the internet. And you see that there's drills on the legs and it could go and mine stuff. What happens if you have to change the programming, the code, over a low-speed data link? Okay, if you compile C, you get this big binary blob, right? Every time you want to change a code, you got to make this new binary blob, and then you got to send it out a low-speed data link out to Pluto, and then you have to reflash the processor up there. Well, if we had Forth that was at the other end, and it was the high-level processor in the system, then you could change programs, because you could make keywords deferred words. We all know what deferred words are, and then you could very easily reprogram, the important pieces of Forth, and you could, of course, interactively debug it over a 9600 baud data link, no problem. So that's kind of the issue we're talking about. So here's kind of an example of that. You got a dish, and you're talking to these robots that are scattered around the solar system. And are you really going to upload a multi-megabyte binary blob when you change one line of code? That's the C way of doing it. Forth way of doing it, you send up 80 characters and you reprogrammed it, right? You change a line of code. So I really think Forth has a lot of a big future. I am working to get it into made in space products. I got a couple people interested in Forth. We have a software bi-weekly meeting, and I've given an hour-and-a-half presentation, and I talked about this very problem, because otherwise it's like, why do I want to use Forth? I can use C. Well, wait, you got a little problem with this low-speed data link. So I got people interested, and I'm trying to get on the team that's going to be writing this stuff. And what I want to do is put Forth at the top of the heap here for the COM processor. So this is kind of where I would see it. Now, when I said those words, one of the programmers said, "Oh, so we hire programmers to work at Made in Space, and they have to learn a new language?" How many languages do each one of you know? You know more than one, right? You know more than just Forth. You know C, you know all kinds of stuff. I mean, that's part of the job. But it was an interesting comment. So what I envision is you have the Forth command processor, and that's tied to the low-speed wireless link. And then you have the RISC-V. Everything is in an FPGA, because the FPGAs are radiation hardened. So so we have a Forth command processor like what Ilya's doing, and Dr. Ting has a Forth processor, and we have a couple other people working on FPGA Forth processors. So that's what this would be, would be a Verilog based Forth processor, or VHDML. And then you'd have the RISC-V core, and that's for the C guys. So, you know, they could have all kinds of stuff going on, and they can go ahead and compile stuff in C and C++, keep them happy. But let's make the fourth the interface, the master processor of the system, and we can change the programming very quickly on the fly. We can do debugging, you know, using the interpreter, you know, all the good stuff that fourth does. And we don't have to let go all the C programmers. And then at the lowest level, in the FPGA fabric, you know, you use Verilog. So the advantages of fourth, obviously, you all know them. Incremental compiler, it's a meta language. You know, create does is the two most powerful words in fourth. Deferred words, especially in the space environment, is really important. So very key words you know you're going to change, you make them deferred words. And then you could have one or more multiple fourth processors inside the FPGA. I'm going to show you what I'm doing at work, and it'll kind of give you an idea where I'm going. This is our president.
Don, when you activate a video, you have to make 2 clicks to turn the sound on and say that it's motion video.
Do what?
How about, can you do a restart on that? When you go to the video, you need to select 2 boxes at the bottom. One of them says use computer sound, and the other one says something about smooth content for transmission.
Let's see. Screen. Okay, well, what do I see now? So you're talking the lower left?
No, it's on share video.
It says something like share video, and it says use computer sound.
Left where the camera is. Left below.
Where the camera is. Well, I'm in the shared screen. Oh, here it is up here, I guess. Under more, share computer sound, optimized for video clip.
Video settings.
That's it, select both.
Okay, I got one of them. Okay, they're both clicked. I'll try it again. Come on, wake up. Now it's not starting the video after I did that for some reason.
Is that video on YouTube or a place so we see it?
It was on.
What you could do is send us a link to it and move on, because time is short.
Okay, well, this is the actual project that I'm working on right now. Can you guys see the video okay? You guys see in the video?
It's a little jerky for me, but you need to be wrapping it up pretty soon, Don.
All right, well, the other one was an intro, it's 4-minute video. This is a 2-minute video. So this is called Archinaut 1, and it's you see the white in the solar panels is a 3D lattice beam that we're 3D printing, and as we're 3D printing, we're unfurling solar film. So the solar film is on a roll, and so we're making a 10-meter, which is over 30 feet. We're making a 10-meter beam, solar, basically solar array, and then it's going to, that arm there is going to pick up the the extruder and then flip it over to the other side. So we're demonstrating manufacturing a major component in outer space. It'll be the first time in history. And I'm working on the flight computer for that. I'm just finishing it up, as a matter of fact. So then it prints the other side. So, so that's basically my presentation. That's my contact info. If anybody needs, like to talk to me about it, and let me stop sharing and then I'll take questions. Okay, any questions?
What about repair in space?
We're going to be doing that too. Yes. Yeah. So I'll put the link in our chat for those 2 videos, and you can go take a look at them. The 4-minute video on Made in Space is excellent for understanding what the company's doing and our goals. We have many different things on the space station. We're growing crystals in space. We developed a machine to make fiber optic in space, and that's going to be going up within a year. Fiber optic and crystals will be absolutely perfect in space because there's 0 gravity. There's a lot of 0 gravity stuff we can make in space that you cannot make on the Earth, and Made in Space is working on all that stuff.
Things like zone refining are so much simpler in space.
Mm-hmm.
Yep.
So yeah, that's what we're doing. It's exciting, and I think they need to use Forth. So I'm going to be pushing it over the next year. We'll see if I. Hopefully next year I'll do a 4th day on how we use Forth at Made in Space. Any other questions? Okay, I guess I'm done.
Don, with regard to the AI bot board, is it something that one could buy now? How much does it cost? When might one expect delivery?
Yeah, well, I want to get it working first before I sell any more, but I've been selling the boards at cost, which is $50. So there's been about 8 people in SV Fig that have 8 boards been sold, and I know Dr. Ting ordered 2 of them. So
coming soon, and
yeah.
You'll be in touch with us about that. And if you want to work on the project, Greg Willis says he wants one. If you want to work on the project, you should contact Don. And if you can't remember or can't scroll back or go to YouTube for his contact information, you can contact me through Meetup or at Forth or at Comcast.net, and I will forward it on to Don. Speaking of products, I'd like to say 2 things. First is Joseph O'Connor, are you on deck?
I'm right here.
All right, wonderful. The second thing, we can hear you great. You'll be on in just a second while I give me a moment to blather about one other thing. The 4th product of the year. You've heard me talk about this before, I'm sure, but I'm going to talk some more. It's the Dazzler. If you want HDMI video for your AI bot, or for your Arduino, it's something that begins with A. You can buy one of these things, and they're very reasonably priced. And way to go, Mr. Bowman, for producing this thing. He actually builds stuff and sells it. I'm just amazed. There's an actual Forth processor in there, so it's something that we see too little of in this world. So on that cheerful note, Joe O'Connor, introduce yourself, please.
Okay, I'm going to share my screen now. Okay. Um, okay. Um, I seem to have a problem sharing my screen.
What operating system are you on?
I'm using my Apple, my MacBook.
And are you using the Zoom client, or are you using the web?
I'm using the web. It has me on desktop too, and then I'm trying to share my screen.
You,
It allows Zoom to share your screen, open system preferences.
yeah, you may have to allow it in.
Okay. All right. Can everyone see it? No.
After you've allowed it, you might need to try to share again. Are you?
Okay.
There we go.
Okay. Very good.